Hi everyone, this is Aruna Arichami, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the example of view serializability and conflict serializability. Before that thing, we're going to see about what do you mean by conflict serializability and view serializability, and also why we have to go for a serializability. If I want to equivalent this serial schedule, that is we're going to convert our non-serial schedule into an equivalent serial schedule. For that only we are going for a view and the conflict serializability. In a non-serial schedule, we couldn't able to conclude the particular schedule inside that particular transaction can be executed in a serial manner. So for checking that only we are going for this non-serial schedule or a serializability. Conflict means if there is any non-conflicting operation, that is while swapping of transaction, is there any conflicting operation is present in that particular schedule. For that only we're going to check it over here. For checking the thing, we're going to see the different thing. This, if my transaction is between read write, write read and write write, in this case only a conflict serializability can occur. If it is a read read read, there is no conflict serializability is occur. And also based on this thing, we're going to draw a precedence graph. Inside the precedence graph, if the cycle is present, then we can say it is not a conflict serializability. So if it is not a conflict serializability, that particular transaction may or may not be a view serializability. Definitely in this case we're going to check the view serializability. View serializability is purely depends upon the dependency how the transaction can be executed. For that thing, we're going to consider the three things. First one is, first we have to first write. Second thing is we're going to consider the first update or read. The last we're going to consider as a last write. Based on these three conditions only, we're going to check whether the given schedule is a view serializable or view serializability or not. Now we're going to see along with the example. Consider this particular example. It will have a 4 transaction T1, T2, T3 and T4. T1 it will have a R of A, R of A, R of A, and similarly it will be depends upon the A data item. This will be depends upon the B data item. Now we going to check the dependency. So while I am considering the transaction 1, that is the first transaction can be executed in that particular thing. If it is a read and read, that is not a problem, and also it will have a read and write, but A, this is a data item is A, here data item is B, so we doesn't need to check the thing. Similar how if I check the 4th thing, it doesn't have a conflict because it will have a read and read. So read and read is does not have a conflict. So next I am going to check the W of B. While considering this thing, definitely this particular case a dependency is occur. That is between T1 and T2, T1 and T3, T1 and T4, it is a dependency. Similar how if I check with the T2, it will depend on T2 to T1, T3, T2 to T4. While checking this thing T3 to T4. So for this particular schedule, we're going to draw a precedence graph. So based on this thing, I am drawing the precedence graph. I am having the 4 transaction here T1 to T2. I have drawn this thing T1 to T3, T1 to T3, T1 to T4, T2 to T3, T2 to T4, T3 to T4. So T4 to T4 doesn't have the thing. So we're going to leave as it is. So based on this thing, we're going to check is there any cycle or not. So while seeing this thing here doesn't have any cycle is formed. So definitely we can say this is a conflict serializability. If it is a conflict serializability, definitely this will be a view serializability. We doesn't need to go for checking the view serializability. So this is the first case. In my second case, I am going to explain the thing with the different example. In this case, it will have a 3 transaction. Here in this transaction, T1 does not have connection with the T2 because it is read. But T1 it will have a connection with T3. So this is a read write. So that going to be considered over here. While considering transaction T2, it will have a connection between T1 as well as the T3. So this is a T3, this is a T1. But T2 to T3 and T2 to T1. So next, by considering the transaction 3, it will have a connection with the T2 alone. So T3 to T1. So based on this thing, we're going to draw a dependency graph. While drawing this dependency graph, can be depends on these things T1 to T3, T2 to T3, T2 to T1, T3 to T1. So in this case, there is a cycle is established between these three. That is a T1 and T3. Again, T3 can connect with the T1. So this is a cycle. So in this case, we can say it is not a conflict serializability. And also, it may or may not be a view serializability. Definitely, we have to go and check the view serializability. In the view serializability, first we are going to check the three condition. One thing is a first write, that is a read write. Second thing is first update or read, that is a first write read. The next thing is a last write, that is a write to write. That condition we are going to check. In this case, last write will be a definitely T1. So there is a dependency between T3 to T1. This is a last write. The next thing is a first write is the first read write is the this one. That is a T1 to T3. So again in my dependency graph, this particular transaction can have a dependency. So we can conclude that this is not a view serializability. So in this example, definitely it is not a serializable. So next we going to check whether it is a non-serializable. Definitely it is a non-serializable. Finally we can take whether we can able to recoverable or not. That we going to see it in the next class. Thank you for watching my video.